We have cracked a 10-character password in 8 seconds using a GPU in this laptop. The password was 02012341000. Less than a second to crack that password. 11-character, or in this case, 11-digit password cracked so quickly. Don't just use digits in your password. This video is part of my free Hashcat course. Use the link below to see the whole series. Hopefully you're learning a lot. Please don't forget to subscribe to my YouTube channel if you enjoy this type of content and like the video. In this video, I'm going to show you how to crack Wi-Fi passwords, both simple as well as more complex passwords. We're going to be using a brute force attack in this example. So no word lists, we are using brute force attacks against these Wi-Fi passwords. In the previous video, I showed you how to attack a Wi-Fi network and capture information from that Wi-Fi network and get the hashes so that they can be cracked. So have a look at that video if you don't know how to do that. In this video, I'm assuming that we've got the hashes already and we're simply going to crack them. Now, brute force attacks can take a long time. In this example, I'm going to show you some easy examples and more complex examples. Your mileage will vary depending on the GPUs that you have and the passwords used and the number of combinations that you have to try. An 8-digit password is going to take seconds to crack. Longer passwords, let's say a 20-character password or a 30-character password, is going to be almost impossible to crack. Really depends, however, on if the attacker can use some interesting switches to make it easier to crack. But let's get started. In this example, I've got a Windows 11 computer. It's got a GPU in it, and we're going to use Hashcat to crack the password. Again, in the previous video, I showed you how to download Hashcat and install drivers, so I'm not going to show you that here. If I type dir here, you can see that I've got a bunch of hashes of various lengths and descriptions that I can use to crack. I'll clear the screen, and let's run an attack. So here's my first example. I'll explain all of the details as we go through this video, but notice that password took 2 seconds to crack. As I've often said in videos, don't use your telephone number as your Wi-Fi password. In this example, the password was a London number, so 020 followed by some digits. Very bad password. 1 or 2 seconds to crack that password. Don't use your telephone number as your Wi-Fi password. Now, whenever I say that, I get a lot of comments saying, David, that's dumb. People don't use their telephone numbers as their Wi-Fi passwords. Well, here's an example from the real world. A security researcher was able to crack Wi-Fi passwords at scale. So he walked around capturing Wi-Fi password information. In this attack, he didn't have to have clients connected to the Wi-Fi network. He could simply use a Wi-Fi adapter and attack various Wi-Fi networks. In this example, he cracked 70% of the Wi-Fi passwords out of a sample of 5,000 because they were using their telephone numbers as their Wi-Fi passwords. Here he used a GPU rig to crack the passwords. In my example, I'm simply using a GPU in a laptop. He used a similar trick to what I've just demonstrated in that he guessed that the first part of the Wi-Fi password was a telephone number beginning with 05. In my example, I have guessed that the first 3 digits of an 11-digit password start with 020, which is the London dialing code. So this happened a few years ago, but he cracked 2,200 passwords using that. And then he used brute force and other attacks to crack the rest of the passwords. 70% success rate out of a 5,000 sample. The point I'm making through that is you may be using a good password, but a lot of people don't, unfortunately, in today's world. We need to educate them and make them aware that passwords need to be good. Here's an example from the National Cybersecurity Center in the UK, and it gives us a list of the top 100,000 passwords from Have I Been Pwned. Notice these passwords, terrible passwords. So an example would be Spider-Man. Don't use a password like Spider-Man or Superman, even with digits on the end. Notice how people use passwords and they make them more secure by putting a digit at the end or a special character at the end. So notice a lot of these passwords have a word followed by a digit at the end. This is a really bad way to set your passwords, and I'll show you in a separate video how you can use a password list and then change something on the end to catch passwords like this. In this video, I'll show you how to do that with brute force. So SecLists is also another great resource of passwords. They have Wi-Fi WPA passwords here, so probable top 447 passwords or 4,800 passwords. And notice how bad these passwords are. There you go, Superman again, or I love you, etc. Unfortunately, people use terrible passwords like this even today. Make sure that you educate others so that they're aware that they shouldn't use bad passwords because they're really easy to crack. Okay, but let's crack a more difficult password as part of this demonstration. I'll clear the screen here. So in this example, I'm going to crack a 10-character password. It's mixed characters. I'm going to increment from 10 to 18. So I'm starting at 10 just to speed this up rather than starting at 8. So I'll press enter. Hashcat is starting. According to this, it'll take more than 10 years to crack. It's taken 1 second so far. Press S again to get an update, but actually it's already cracked it. We have cracked a 10-character password in 8 seconds using a GPU in this laptop. So what we did here is notice the mask is 10 characters. I'm specifying that the first 9 characters are digits, or lowercase or uppercase characters. The last character is a special character. So an example would be exclamation. Now don't try and remember all the options in Hashcat. Simply type hashcat --help and that will give you all the options available in Hashcat. So L is lowercase characters. U, uppercase characters. D is digits. H means these digits and characters. Lowercase. Uppercase H. Special characters. A means lowercase, uppercase, digits, and special characters. And B gives us these special characters. The mode is shown here. So as an example, 3 is brute force. That's why when I use the hashcat command, -A3 means brute force. And going back to our characters, notice I used digits, lowercase, and uppercase, and then I used S at the end here, meaning special characters. And again, I'll explain all of this in more detail as we go through this video. I simply want to show you some options right in the beginning. A Hashcat can crack many types of hashes. It's quite difficult to show you this through the terminal, so what I'll simply do is clear the screen and let's take that help file and pipe it into hashcathelp.txt, and then I'll open that up in Sublime Text. So there's the file that I've just created, and notice we can see this is a long file, a lot of information available through the help screen on Hashcat. So as an example, M means hash type. So again, in my command, M here is the hash type. What is 22,000? That is Wi-Fi. So I'm cracking a Wi-Fi password. D is device. The first D is device, as in the device that I'm using is number 1. So as we can see here, back-end devices. In my example, that's the GPU. So typing hashcat-I, big I will show me the devices. So scrolling up here, hashcat-I, we can see that we have an NVIDIA GeForce RTX 4090 laptop GPU. So the device or backend device is listed as number 1. So if I want to use the GPU in this laptop, I have to specify device 1. If I want to use the CPU, I would specify device 2. So in my command here, I'm typing hashcat, backend device is 1. I have specified W here to increase performance. This gives me a workload profile, and we're told to see pull below. So looking at our workload profiles, notice 3 is high. Desktop impact is unresponsive. Number 4 is nightmare. So insane power consumption. It's headless. So let's run it again with number 4 using nightmare. What I've got to do is delete my pot file first. So I'll delete this pot file because if I open that up, you'll notice that the passwords are stored in that file. So you can see it cracked that password and there it is. So I'll delete that. So let's make this nightmare. So workload being nightmare. What you'll notice is when I type S to try and get status, I'm not seeing anything. It's taking longer to show the output. Don't know if you can hear that, but the laptop is going crazy here. What's interesting, it's actually taking a bit longer. So this actually took 1 minute and 6 seconds, even though I'm using nightmare mode. So the previous example took less time. So you'd have to check whether using high or nightmare mode works better for you. I tend to use high, and that works better for me. So workload being 3. A again means the attack type. So in my example, the mode or attack type is brute force. Again, we can see that in the Hashcat documentation. This, again, is Wi-Fi. So Hashcat, GPU, high performance. Attack mode is brute force. It's a Wi-Fi password. This is the name of the file. So TP-Link default 8 digits. That's the file in the directory. So if I open up another window here and type dir, you can see the file here. So TP-Link default 8 digits. So that's our hash. And here I'm specifying how to crack the password. So D means digits. Question mark is saying character set. So what are we doing here? We're assuming that the first character is a digit. Second character is a digit. Third character is a digit. Fourth, fifth, sixth, seventh, and eighth. So we are saying that this is an 8-character password, but it's 8 digits. Now, I know that because I captured the information. You may not know that, and hence we want to use a range and use different characters, and as I've demonstrated and will demonstrate in a moment. So this is an easy one because it's 8 characters, and I know that it's digits. So when I press S for status here, I can see that this is an 8-character password, but they're all digits. It'll take as a maximum 1 minute and a bit. So it's 13 seconds, 12 seconds, etc. to crack this according to Hashcat. This is the default password on my TP-Link router. TP-Link are awful. And there you go. Password has been cracked. Notice there it is. Took 44 seconds to crack that default password. So on this TP-Link router, you can see hopefully the default password used. TP-Link are awful. 8-digit passwords are the defaults. And unfortunately, a lot of people use the default passwords. I would never recommend that you use a TP-Link router, especially the default passwords. This has also been in the news 6 days ago at the time of this recording. We can see that US officials say TP-Link routers are dangerous. Here's what experts told us. One congressman told us don't use this. So in this article, they talk about TP-Link has known security flaws, but so do all router companies. And in this article, they tell you how to protect yourself if you do have a TP-Link router. And I mean, this is basic advice. Keep your firmware up to date. Strengthen your credentials. Notice if you've never changed the default credentials, make sure you do that now. Weak passwords are the cause of many common attacks. So easy to crack TP-Link routers if they use the default passwords. Don't use them. Consider using a VPN service and then have a look at other routers. But as I say in this article, average people are not necessarily going to be the targets of a massive attack. But it does happen that Wi-Fi routers are attacked, as in this example where a Wi-Fi network was compromised and used to attack a US government organization. Here's another TP-Link router, same problem. Hopefully you can see that. Same problem. Another so-called very good Wi-Fi router that has a really bad password. Don't use the default passwords on devices like these. Change your password and make it much more secure. Okay, so I previously showed you an example with 8 characters. Here's another example with a 10-digit password. So you should hopefully know these options by now. We're using the Hashcat command. The device is device 1. That's the GPU in my computer. This means high performance. The hash type, we are using a brute force attack. The type is a Wi-Fi password. This is the file name, so the hash. Again, dir in my directory. You can see there's the hash TP-Link 10 digits. And what I've done here is specify digit as the first character. Same for second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. So 10 digits. So we're guessing the password as a 10-digit password. I'll press enter. Hashcat is starting. I'm going to press S to look at status. You can see that's what's shown here. The mask is a 10-digit password. According to this, it'll take 2 hours. Notice Hashcat is running. It's a Wi-Fi password. I'll press S again. Now, actually, it's already cracked it. So that took 5 seconds to crack. So this 10-digit Wi-Fi password, that's the Wi-Fi SSID or the name of the Wi-Fi network. The password is this. So this Wi-Fi network with that 10-digit password was cracked in 5 seconds. So again, that's the file name. The type is a Wi-Fi password. It's been cracked by Hashcat in 5 seconds. Again, 10 digits is what we're using. This is showing the candidates that it's trying to use to crack the password. We can see the speed here, so 993 kilohashes a second. That was using the GPU. Hashcat-I shows us the GPU that we've got in the laptop. Scrolling up, we can see that this command shows us that we have a NVIDIA GeForce RTX 4090 in the laptop, as well as a CPU. But because we used in that command device 1, it's using the GPU to crack this password. So 10-digit password isn't necessarily very good, very easy to crack. But as I showed you before, we can use Hashcat and specify other characters in the beginning of a password to speed this up. So again, Hashcat device is 1 GPU, high performance. We're doing a brute force attack against a Wi-Fi password. This is the name of the Wi-Fi password, 11 London digits. We are going to increment in this example, and I know that's an option a lot of people want to know. If you don't know the length, you can increment it as follows. So -I or -- increment. The minimum that we're specifying here is 11 digits. Maximum I'm specifying is 18 digits. So I have created an 18-digit option here, but it starts with 020, London dialing code, followed by digits. So when I press enter to crack that one, and I'll press S to see status, it's actually already cracked it. It took it less than a second to crack that because the password is so bad. So I'll just zoom out here, but the password was 02012341000. Less than a second to crack that password. 11 character, or in this case, 11-digit password cracked so quickly. Don't just use digits in your password. Make sure that you mix your characters, uppercase, lowercase, special characters, etc., and make it long. So again, this was sped up because we knew the first 3 characters were 020, followed by a bunch of digits. The range that I specified was from 11 to 18. Now, in a lot of these examples, I'm speeding things up so that we don't just have to watch the GPU crack the password. In some of these examples, it could take a lot longer. I just got lucky cracking the password. So in this example, where it took 5 seconds to crack this password, 10-digit password, it could have taken it 2 hours and 47 minutes in the worst case scenario. I got lucky, got cracked in 5 seconds. In this example, with an 8-digit password, it was cracked in 44 seconds. In the worst case scenario, it would have taken something like 1 minute and 41 seconds to crack that. But again, I was able to crack it a lot quicker. It only took 44 seconds. Now, a lot of people, again, are probably complaining that I'm only showing easy passwords with digits. So again, let's do a more complex password. So again, I'm running Hashcat with GPU, high performance. It's a brute force attack. It's a Wi-Fi password that we're cracking. This is the file. It's a 10-character mixed password. And what I'm doing here now is specifying a group. So group 1 is saying digits, lowercase, uppercase. So first 9 characters in this example are uppercase, lowercase, digits. Notice -1 here. So I'm saying character 1 is part of group 1. So it'll be one of these. Character 2 is part of this group, be one of these options, digits, lowercase, uppercase. And I've done that for the first 9. And then I'm saying S, special character at the end. So the character set that I'm using at the end is special characters, because remember, a lot of people will think that their password is more secure if they put a special character at the end. How many of you type a password, in this example, like I love you, exclamation mark, or Spider-Man, exclamation mark, or word with a digit at the end? So let's do a special character first. But what you could do, rather than using special characters only here, at the end, I could have created another group, group 2, and said digits or special characters. But for this example, let's just specify special characters. We're going to increment from a minimum of 10 to maximum of 18. WPA Wi-Fi passwords have to have a minimum length of 8, so I could have specified 8 to 18. But just to speed it up for this demo, I'm going to use a minimum of 10 and press enter. Now notice what's happened here. I've already cracked this password, so we have to use this option --show at the end to see the output. So if I type --show at the end, you can see that's the password already cracked. So what I'll do is go into my directory and I'll delete the pot file because the password's already there, and I'll clear the screen and run that again. So take show away at the end and press enter. And now it's going to try and crack it again. So we're doing the whole thing again. According to this, could take 10 years to crack this password. But I was very fortunate. Password has actually already been cracked. There it is. So for this Wi-Fi network, this is the password. Took 8 seconds to crack. Again, I just got lucky here. That is the hash file. And let's explain the details again. So it's a 10-character password. I did say the length is from 10 to 18. So if it hadn't cracked it at 10 characters, it would have then tried 11, then 12, then 13, up to 18 in my example. Group 1 consists of digits, lowercase, uppercase. First 9 characters are going to be uppercase or lowercase digits. I haven't defined group 2, I haven't defined group 3, I haven't defined group 4. I've simply said special characters at the end. And notice that is the password. First character is a digit. Second character is uppercase. Third character is a lowercase. Rest of characters are lowercase. Last character is a special character as found in this list. Now you could try all characters. So A, that's going to take a lot longer, however. So rather than specifying everything, lowercase, uppercase, digits, and special characters for every single character, we're hoping that the user did what a lot of users do. First character is uppercase, remaining characters are lowercase, and then a special character or digit at the end. Makes it a lot easier to crack. But let's assume for this example, we're going to use Hashcat with the GPU, high performance, brute force, Wi-Fi password. This is the name of the file, and it's 8 characters, but any characters in any part of the file. So this is only 8 characters now. According to this, it'll take 210 years. Notice it's going to take a lot longer because it has to go through every single combination. Now again, I got lucky here, 9 seconds to crack this password. So here's the password again. All characters are A. So notice 8 characters, A meaning anything. So first character in the password was a 4. So that's true. A is a digit. A includes digits. Second one, special character, or second one, special character. So A. And then we had uppercase in the third position. And then we had lowercase for the rest. So I got lucky here again, 9 seconds to brute force, 8-character password. So password is cracked. It's a Wi-Fi password consisting of any type of character. Notice this range gave us that as the password. Digit, special character, uppercase, or lowercase. I was able to crack that password. If I run this again, notice we're told that we need to use --show to see the password. So if I press enter now, it tells us that's the password for this Wi-Fi network. Now, previously I showed you how to crack a 10-digit mixed password with a group of digits, lowercase, uppercase, in the first 9 digits, and then a special character at the end. Now, what you could do is create a group 2 here and say that the second group is going to be digits as well as special characters. So rather than limiting the last character to just special characters, I could create another group saying the last character in the password is either a digit or a special character. So notice the first 9 are going to be digits, lowercase, uppercase. Last character is going to be digit or special character. And I'll press enter there. I've already cracked this password. So what I'll do is go and delete the pot file. So delete that. And I'll run it again. S for status. What you'll notice is the last character is a digit. So first 9 characters are going to be lowercase, uppercase, or digits. So you can see uppercase and lowercase in that example. Type S here, where you can see uppercase and lowercase, digit at the end. This just means it's going to take longer, 10 years, because there are more combinations of passwords that we have to crack. Notice how many we have to crack in this example. It's going to take a long time to get through all of these passwords unless we get lucky. So what I'll do is quit this, and we could try things now. A lot of this is just going to be trial and error. We could say that the third group is going to be digits or special characters over there. Now, because this is a human, I'm going to assume that they're using uppercase for the first character. Then they're going to use the lowercase for the next few characters, and then digits or special characters at the end. So I would change all of these to be 2. So first character in the password is uppercase. The remaining characters are going to be lowercase. And the final character is going to be a digit or special character. So if I press enter there now, we should see something similar to that. We should see that. Notice we've got group 1, group 2, group 3. We haven't created group 4. Group 1 is uppercase. So you can see in the output here, uppercase. So we can see that digit 1 is using group 1, which is uppercase. So we can see M, uppercase. S for updating, you can see uppercase G. The remaining characters are lowercase. So all of these are lowercase, except for the last character, which is going to be either a digit or a special character. So hopefully you can see in that output, that's exactly what Hashcat is doing. The first character is uppercase. That's an O, so that could be confusing, but here's X. First character is uppercase. Remaining characters are lowercase, and the last character is a digit at the moment. You'd have to leave it to cycle through all the combinations until we see like special characters here. But you can see it's going to take 7 years, according to this, to crack that password. So it helps to look at human nature, like I love you, exclamation at the end, or Raiders, 1 at the end, or lowercases 1 at the end here for a random password. A lot of these passwords are really, really easy to guess, not difficult passwords to crack. On sec lists, again, they have top Wi-Fi passwords. So if we look at the top 62, I mean, people are using passwords of password, or 1 to 9, or football, Superman, I love you. Really bad passwords. So notice how bad those passwords are. If we look at a bigger list, same kind of bad passwords shown here. Moral of the story is use good passwords on your Wi-Fi networks. Make them very long. Hashcat will not be able to crack longer passwords. So this password, as an example, is taking much longer to crack. If I tried to crack, let's say, a 10-digit password, and we just made it any character, so we would go A 10 times, that's not going to even work. Notice it says overflow. It won't even allow me to crack that password. Too many characters, it says. If I make it 9, it will do 9. But notice it'll take to the next bang. So it'll do 9 of any character, but it won't allow me to do 10 of any character. Overflow detected. And that's now when I have to try and guess. Are people using uppercase in the first position, special characters at the end, etc.? So in today's world, it's very easy to stop this kind of nonsense. All you need to do is use WPA3. Don't use WPA2. So first step, use WPA3. Second thing is use a complex password. Don't use the default password on your Wi-Fi network. Make it a complex password. So make it like 20 characters in length, mixed characters. Or, as a lot of people will say, is use words in your passwords, but make it a long sentence. Don't use a password like I love you. That's too simple. But you could use a sentence that's easy to remember with characters in between, or just use a really complex random password. With security, it always ends up like this. Ease versus security. Do you want ease of use, less security, or better security, harder to use? But for me, I like using very long passwords, mixed characters, uppercase, lowercase, all kinds of random characters. Not easy to use, but I know it's a lot more secure. And actually, I prefer using wired rather than wireless. Wherever possible, I'll use a wired connection. Makes it a lot harder to attack. Now, let's show you an even more complex example. In this example, I'm going to use Hashcat with my GPU, high performance, brute force, Wi-Fi password. The file that we're going to attack is this mixed password, 10-digit password. So I'm going to increment from 10 to 14 characters. But what I'm going to do here is use a mask. Now, if you don't specify a mask, if you just specify that by default, Hashcat is going to use the default mask to crack the password. So if I take that and copy that into a terminal, it accepts the command. And if I type S to see the status, what you'll notice is it's using this mask. It's got group 1, group 2, and group 3. Now, we didn't specify that. It just did that by default. 8-character password. It's going to take 65 days to crack this password, it says. So if I type S again, notice 8 characters. It's at this point now. First character is lowercase digits, uppercase. Second character is lowercase digits. Third is these special characters. Now, the question is, how did it know to use those characters? How did it decide to use that? And I'll quit this now. That's because it's using a mask. So in my Hashcat directory, there's a directory called masks. And inside here, there is a default mask that Hashcat will use. I'll open that up with Notepad as an example, and what you'll notice is these are the characters that it's going to use. So lowercase, digits, uppercase, comma, lowercase, digits, comma, lowercase, digits, and special characters, comma. So before the comma, this is the first group over there. We have the second group over here, and then we have the third group over here, and then we have digits at the end. So what it's assuming is first character will be one of these. So 1, 2, 3, 4, 5, 6, 7, 8. So notice 8-digit password. It's assuming it's going to be that. Going into our actual Hashcat, we can see that's exactly what it decided to do. If it went to 9 characters, it would then specify group 3 at the 8th and 9th position, and so forth and so on, and then digits at the end there. It's trying to guess human behavior. But that means we can also create our own mask. So here I've created a mask myself, which I'll open up with Sublime Text. And what I've told it to do is for an 8-digit password, do this, very similar to before. For a 9-digit password, it's going to do this now. For a 10-digit, it's going to do this. And then it just does that for the rest. So for 11 digits, we could decide to do something else. So I'll copy that and paste that there. So I could say, let's do that for 11 digits. So 8 digits, 9 digits, 10 digits, 11 digits. And you could just change this as you decided to. So we have got different options for different length of passwords. So what we're doing for this file now is specifying where our masks file is. We've got a file called Wi-Fi mask, which is this file over here in the masks directory. And then we're incrementing. So I'll increment this from 8, even though it won't work because this is a 10-digit mixed password. So I'll start at 8 and then I'll show you the options. So I'll clear the screen here. Remember now that we're starting at 8 characters going to 14. We are cracking based on our mask file. So I'll press enter now. At 8 characters, we've got uppercase in the first position. That's correct. Uppercase in first position. We've got lowercase and digits in the second position. Second position are all of these characters from number 2 to number 7. That's what we've got there, lowercase and digits, second position to 7th. Third position should be lowercase digits as well as these special characters. And that's what we're seeing over there. So we've got 3 there. So again, if we look at the output, first character should be uppercase, which it is. These characters should be lowercase or digits. So we see lowercase at the moment. Over there, here we see a digit. Last character will be lowercase, digits, and special characters. We're seeing lowercase at the moment. So if I say S here, there you can see it's a digit now. So digit in the last position. We're also seeing digits over here in a number of places. And that's true based on number 2. Also seeing digits right down here, which is true based on position 2. Includes digits. Now it'll get to special characters eventually. It's just got to go through all the different combinations. But notice the first character is always uppercase because we specified uppercase there. These characters are lowercase or digits as we've got over there. And then the last character will be either digits or lowercase or these special characters. So that gives us a lot of options. Okay, I'll quit this now. Let's start at 9 rather than 8 to make sure that it's doing what we expect it to do. So I'll paste that in. We're starting at 9 now, not at 8 characters, just to prove the point. So it's done that, 9 characters. And notice same thing again. First character is uppercase, as shown over there. 2, 3, 4, 5, 6, 7, 8 is group 2, lowercase and digits. And the last character are these special characters as well as lowercase and digits. And that's exactly what we're seeing here. So S again, first character is always uppercase. These are either digits or lowercase. And then the last character is either a digit or lowercase, as we've got over there, or some special characters. And again, you just need to wait for it to go through all the combinations. But it's going to take 2 years to crack this password using those options. Okay, so let's make it 10 characters. But for here, let's change the mask to 3 for the last 3, just to prove the point. So I'll save that file. So 9 now. So let's try 10 characters. But what I've done now is change these to something else. So we'll start at 10 now. Let's see what that does. So I'll clear the screen, paste that in. We're going from 10 to 14 now based on our mask. Hopefully I've updated the right mask. And I have, as you can see there, notice the last 3 characters are group 3, which is these. So what you'll notice is digit in the front, because I actually said digit in uppercase. Let's just make sure I did the right file. So yeah, actually here I've left it as digit in uppercase, so that's correct. So group 1 is digit in uppercase. Group 2 is lowercase and uppercase, so slightly different. And then group 3 is this. So I didn't check my file properly, but it's done exactly what it's supposed to have done. Group 1, here's group 2, there's group 3. Group 2 is lowercase and uppercase, so no characters, so no digits here as an example, but we can see uppercase and lowercase. But the last 3, we can see digits or special characters. So again, notice we're just seeing digits at the end there, and then eventually it'll go through to special characters. The first character, however, is either digit or uppercase. So we'll see something different here. Right there you can see digit now, because that's what we specified there. And then we've got uppercase, lowercase for these options. And then the last 3 are these options. Okay, I think that's enough. I've done a lot of options here, shown you many, many options. The moral of the story is you have a lot of control in Hashcat to determine what gets used to crack the password in a brute force attack. You probably want to try a password list before you get to brute force. Try and do some clever stuff. As in this example where Matt Brown did a great example, also got a good YouTube video explaining this, where he used Netgear WPA word lists to crack the default passwords on Netgear, because they used an English adjective, then an English noun, followed by a 3-digit password as their default password. So the Wi-Fi SSID would be something like Netgear followed by a 2-digit number, but the password followed this pattern, so they could generate a word list consisting of top English adjectives, nouns, and the characters at the end, mixing that together to crack the password. So the moral of the story is don't use the default passwords, because as in this example with Netgear, they were able to crack a whole bunch of default passwords. TP-Link really, really bad. Make sure that you use long passwords, mixed characters, special characters, etc. So as an example, a 20-character mixed password is not going to be cracked by most people because they don't have the GPUs to do it. Use good passwords in your network.